Okay, so for these examples, we are going to kind of continue on with this idea of synthetic division. What we're really wanting to know is if this value right here is a 0 for this polynomial. What that means to say we want to know if it's a 0, what we're wanting to know is if at the value 3, does this polynomial either cross or touch the x-axis? So that's what we're talking about when we say, is this a 0? The way we know something is a 0 is if when we synthetic divide it, we get a remainder of 0. Basically, that very last number that you get when you do that last addition is 0. If it's anything other than 0, our answer is no. So let's do a problem here. Remember, what we're going to do is we're going to put a little kind of half box here in the corner, which we're going to put our k in. And then across the top, we're going to put our coefficients. And remember, when you have something like x cubed, his coefficient is 1. So we've got 1, 6, negative 21, negative 18. You're going to give yourself a little bit of room and then place a line right below that. Alright, so the first thing we're going to do every single time is we're going to drop that first coefficient straight below the line. Then we're going to take and multiply the 3 in our box times the number we just dropped down. So 3 times 1, we're going to place that right underneath our 6 here. So that would be there. Now we're going to take and add those two together. So we're going to go, well, 6 plus 3 is 9. And we're going to continue on with this pattern. So we're going to do 3 times 9, which is 27. We're going to place that underneath the negative 21. We're going to add that together. So negative 21 plus 27 is going to give us 6. Again, we're going to go over here to our corner. We're going to go 3 times our 6. We're going to place that under the next number, which would be the negative 18. Again, we're going to add that together. Negative 18 plus 18 would give us 0. So we would say yes, k, or 3, is a 0 for this polynomial. Alright, let's try it with the next one. So again, we're going to put in a corner here. We're going to put our k again, which happens to be 3. It's just a coincidence here. Across the top, we're going to put our coefficients, 9, negative 19, negative 28, and a positive 12. Give yourself a little bit of room and put a line. Again, always drop the first terms directly down. Okay, always drop your first one. So then we're going to go 3 times 9 is 27. Negative 19 plus 27 is going to be 8. 3 times 8 is 24. Negative 28 plus 24 is going to give us a negative 4. And 3 times negative 4 is negative 12. 12 minus, or positive 12 minus 12 is going to give us 0. Again, as long as that's a 0, then that means our answer is yes. 3 is a spot where this polynomial crosses or touches the x-axis. Okay, so let's keep going. We got 2 more examples here. We've got one where our k is negative 9. So again, in our box, we're going to put our k, our negative 9. And then we've got 1, 13, 40, and 26 across the top. Again, give yourself a little bit of room. Drop the 1 down. So negative 9 times 1 is negative 9. 13 minus 9 is 4. Negative 9 times 4 is negative 36. So 40 minus 36, that's going to be 4 again. Negative 9 times 4 is negative 36. And 20 minus 36 is negative 10. So our answer here would be no, that this is not a 0 for my polynomial, because my last number that I got out, or my remainder, is a negative 10, not 0. So that's what we're worried about. Now there's another really cool thing that happens, I think is really neat. If I were to take my function and put and actually take negative 9 and place him into all of these x's, and then simplify it, do your negative 9 cubed and your negative 9 squared times 13 and 40 times negative 9, and do the whole thing. The really cool thing that happens is that this value, or this remainder, is actually what it'll come out to be. It's a kind of cool little trick there. So if I actually plugged in -9 into my equation, I would get -10 as the resulting answer. Kind of a neat little thing. The same thing is true for the other ones. Even when it's 0, this is always a true statement. You can always look at your remainder, and that's what you would get if you were to plug that number or that k value in. Alright, so let's try our last one here. With k is 1 this time. So we've got 5 times -5, -2, 5, and -16. Again, leaving myself a little bit of room. Dropping down my first term. Okay, so now I start my multiplication. 1 times 5 is 5. -2 plus 5 is 3. 1 times 3 is 3. So 5 plus 3 is 8. 1 times 8 is 8, placing that underneath our 16. -16 plus 8 is -8. So our answer here again would be no, because we didn't get 0. So again, remember, if this number comes out to be anything other than 0, our answer is no. And then if we find f at 1, that would equal -8. Again, whatever this is what I would get when I stuck in whatever value k that I was looking at. So in this case, we were looking at k equal to 1, so f at 1 would be -8.